Hello everyone, welcome to 𝐿ustraca. So today in this lecture we are going to discuss about a small topic from the draft code of IS 13920 part 1 which is for buildings. So all of you know that the draft of IS 13920 part 1 and part 2 is being wide circulated for everyone so that you can see and comment on it. So today we'll be discussing a small topic from that particular drafts, and we have taken the part 2 which is for buildings basic. So the topic of discussion is how to define a column, or you can say shear wall, which element we shall design as a column, which element we shall design as a shear wall, or you can say structural wall. So in our current code also we have some provisions, and we will see what this draft code is giving us regarding this particular topic. Okay, so let's jump into the current code. So IS 13920:2016 is our current code for ductile design and detailing, correct? And so I will directly go to this clause of 7.1.1 and 7.1.2. So the 7.1.1 is talking about the minimum dimension that a column shall have. Okay, so it is saying that the dimension of column shall not be less than 20 times dB. dB is nothing but the diameter of the largest diameter of the bar, which is you can say passing through the column, from the beam, or anchoring to the column. Okay, so this bar is basically bar of beam. Okay, largest bar that we have provided in the beam, which is anchoring inside the column. So this clause, we all know this clause is provided to provide a seat to that bar so that slip doesn't happen. Okay, so this is one criteria, and another criteria is 300 mm. So whichever is you can say the greater, giving you the greater value, that we need to take as our minimum dimension of the column. Okay, and it should be checked in both the directions. So this is one criteria to decide the initial dimension of the column, and the other one is the aspect ratio. So what our current code is saying, that the cross-section aspect ratio, that is ratio of smaller dimension to the larger dimension of the cross-section of a column or inclined member. Okay, so it is saying shall not be less than 0.45. So basically, if I just tell you, basically this 0.45 is amended as 0.4, correct? So it is saying that it shall not be less than 0.4, which shall not be less than. So if I just draw a column, suppose cross section, suppose this is my B and this is my D. So the code is saying, if you just read it here, the code is saying that the ratio of smaller dimension to the larger dimension. Okay, so we are saying that the ratio of, suppose this is, we will consider this B is smaller than D. So in this case, B by D shall not be, or you can say shall be greater than or equal to, I would write greater than or equal to 0.4. If it is, now if you see, our code is saying that if it is the vertical members of RC buildings whose cross section aspect ratio is less than 0.4 shall be designed as per the requirements of 9. Basically it is not 9, it is actually 10. Okay, so it was also amended, and this is 10, our section 10, which is talking about the structural wall. Okay, so this I will write it again because we'll be discussing on it. So if the B by D ratio is less than 0.4, in this case we need to consider it as column. In this case we need to consider it as wall, structural wall. Okay, so I will write as S wall, which is structural wall. So this is as per our current code. So I will write it here. It is as per our current code. So now what we will do, we will check the same in case of the you can say what is written in the structural wall for the same criteria for structural wall. So if I see the same, the minimum dimension, the minimum thickness of special shear walls, or you can say the structural walls, shall not be less than 150 mm, 300 mm for buildings with coupled shear walls in any seismic zone. Minimum thickness provided must conform to the fire resistance. Okay, so that is about fire resistance, and what it is saying, that if it is a coupled shear wall in any seismic zone, then you cannot provide I can say the thickness of the shear wall less than 300 mm, and I can say generally you can go up to 150 mm. So this is the one criteria, minimum dimension criteria. Another thing is the minimum ratio of length of wall to its thickness shall be 4. Now let us see, we have this dimension, this is by L, so we can consider this as my D. If I consider the wall as column, I mean if I compare the dimensions with the column dimensions, this is my L and this is my T, I mean thickness of the shear wall, and we can consider it, or we can compare it with the shorter dimension of the column, which is B. Now this code, our current code, is saying that the length of wall to its thickness, so L by T ratio, okay, shall be 4. Minimum it should be 4, so it should be greater than or equal to 4. Now if I write it in terms of B by D, so or D by B, so it will be D by B shall be greater than or equal to 4. Now if I change it, if I make it B by D like column, so it should be less than or equal to 1 by 4, which is equal to 0.25. Now you see where is the gap, that here it is saying that it should be, if it is less than 0.4 then it should be wall. Here it is saying if it is less than 0.25 then it should be wall. Okay, so you can understand what is the difference. Here it is saying if it is less than 0.25, less than shall be 4, so it should be less than or equal to 0.25, then you can call it as wall. Here it is saying that it should be less than 0.4, then you can call it as wall. Now which one we should consider? Okay, so this is the problem that we are having now. Then we have different types of walls based on its height that we'll be discussing. Actually we'll have several discussions on this draft code in our upcoming lectures, so please I can say stay tuned for that. As of now we'll be discussing only these two criteria. One is the minimum thickness and the aspect ratio, based on which the code is saying that we can call that as column and call this as the structural wall or special shear wall. So this is about our old code. Now let us our current code. I won't say old code actually. So now what I will do, I will come to the new draft of IS 13920. Now it has become part 2 for buildings and part 1 is for the general criteria. Okay, so now in part 2, similarly I will go to the column area where it is there. So I will just go to, so here you can see column. I will just zoom this a bit, and if I talk about the minimum dimension, it is starting from this clause 13.2.1.1 of the draft code. Okay, so this draft code, now if I see the minimum dimension criteria, it is saying 20 dB, where dB is the diameter of the largest diameter longitudinal reinforcement bar in the beam passing through or anchoring into the column. It is the same as our current code, and then 300 mm, so it is also same as our current code. So this thing we have no issue. Now let's talk about this. Now here we got some clarity. What it is saying, that the cross section aspect ratio, that is ratio of smaller dimension to the larger dimension of the cross section of a column or inclined member. So again the same thing, it is saying that the cross sectional ratio, okay, so it is B by D. This is B, smaller dimension, D is the greater dimension. We say that B is less than D. So in this case, if B by D, what it is saying, shall be more than 0.4. okay, shall be more than 0.4. So in this case we can say that it shall be, I would write, shall be more than, so it shall be greater than 0.4. okay, B by D shall be greater than 0.4. So the vertical members or RC of RC buildings whose cross section aspect ratio is less than 0.4 shall be designed as per the requirement of 13.5. Now there is another problem, I will tell you. Not a problem, there is a mistake actually in this draft code. So it is saying if this is okay, then you call it as column or you design it as column. If this is less than Okay, aspect ratio is less than 0.4. So in this case, you go for designing it as now 13.5. We will see that this 13.5, let me just omit this. Yeah. So if I just directly take you to 13.5, if you see this 13.5 is basically talking about floor slabs. Okay, so this 13.5 is actually mistakenly written, I guess. I hope that it is mistakenly taken, because the 13.5 is talking about, or talking all about, the floor slabs. So here in the column provision, if I see where it is, so we were talking about the aspect ratio. So here this 13.5 that it has written, this will not be actually 13.5, it is basically 13.3. Okay, so this 13.3 is basically talking about the structural wall, right? So here now we have one definition for columns and structural walls, that if it is greater than 0.4, the B by D ratio, then we can call it as column. If it is less than 0.4, then we can call it as special shear wall or structural wall that we'll be designing, or you can say we can design it as the structural wall. Now I will take you to the 13.3, and you will see, okay, here, yeah, so you can see this 30.3 is for structural walls. So now let us see the minimum requirements. The minimum thickness of special structural walls shall not be less than 200 mm. Now 150 criteria is not there, so it is what it is saying, 200 mm for buildings with beams not framing into wall along direction perpendicular to the minor axis. Now here comes the main twist. What it is saying, that you have a wall like this, suppose, okay, and suppose you have some beam connected to this direction, also with the shear wall, or you can say the structural wall. So, and you do not have any beam, or maybe you may not have this beam also, any of the direction obviously will be having beam, but you don't have a beam in the direction perpendicular to the major dimension. So in this dimension, in this direction, you don't have a beam, actually it is not there. Okay, so in these cases, this thickness can be taken as minimum 200. Okay, minimum 200, this is the minimum criteria. So this is about the wall I am talking about. I have not yet come to the point where we can call it as wall. Okay, so one thing we got, that if it is B by D ratio is less than 0.4, then we can call it a structural, I mean we can design it as structural wall. Now we will see in this particular section what it is saying about the structural wall definition. So now we are talking about the minimum criteria. This is one of the minimum criteria. This criteria of 20 dB, it was provided only for the columns in the current revision. But if you see in the draft, basically this 20 dB is for suppose you have a column here and some beam is going through this like this, then suppose you have bar. Okay, so this dimension is providing seating to these bars. Okay, so these dimensions shall be enough to provide, or you can say which can act as a seating to these bars, otherwise these bars may slip during the you can say when lateral force will be applied, you can see we will have this kind of behavior, right? Or maybe this direction will bend, so the bars in this junction can slip, which is passing through the column. Alright, so in this case, this minimum 20 dB dimension shall be provided along each direction based on the what dia bar you are providing. Okay, the maximum dia bar that you are providing, based on that you need to provide the CT. Correct. This criteria should be applicable to the structural walls also, because the structural walls also acting as a you can say vertical, you can say support, right? And you can say providing support to the beams, or can provide support to the beams. So this can happen with the structural wall also. Okay, so in this case, in the new draft code, if you see, this criteria is added in the minimum dimension, which is 20 dB thick for buildings with beams framing into the wall along direction perpendicular to the minor axis at a location where there is boundary, where there is a boundary line. What it is saying? 20 dB for buildings with beams framing into wall along the direction perpendicular to the minor axis at a location where there is a boundary element. So what it is saying, that in this direction, perpendicular to the major axis, okay, along the minor axis. So in this case, what is happening? In this direction, we have enough space, right? But in this direction, if we talk about this direction, if you see, this thickness will be very less, 200 300 mm. I mean, that is why we provide the shear walls actually. One thing is, it has a higher dimension in the in its plane, okay, in its major plane. So basically it has a very high moment capacity, so it can be used for the lateral load resisting element, right? And it will provide higher resistance than the column. So that's why what we do, we use the shear walls with lesser thickness. But when the beam is being connected, okay, along these directions, what is happening? We have a very small space to provide seating to this bars that is, I can say, anchoring to the shear wall, or you can say passing through the shear wall. So in this case, what it is saying, if you have a boundary element, obviously you need to provide a boundary element here, okay, because otherwise how you will be providing that seating, right? So where there is boundary element, in this case, this dimension, why I am showing this dimension, because my beam is coming from this direction, right? So this dimension shall be minimum 20 dB. So dB is nothing but the maximum bar size that you are providing in this beam, okay, in this beam, suppose 1 2 3, okay, in beam 1. Now another one, it says 300 mm for buildings with coupled structural walls. So that means wherever there is a like, just want to tell you one thing, wherever there is a beam connecting to this walls, we need to provide basically a boundary element kind of arrangement, or I can say a column, specifically a column we need to provide there, okay, which is will be acting as a boundary element to the structural one, and also providing seating to the bars anchoring to it from the beams, correct? So it is for the minor direction. For the major direction, we have enough space, so it is fine. That's why it is not mentioned. And it is saying for the coupled structural walls, okay, in any seismic zone, 300 mm is the minimum criteria. So this provision, the first and second, third provision is kind of the similar to our previous, you can say, or current code. Only the thing is, the current code is saying up to 150 you can go, but here it is 200 mm. Fine. Now comes the twist in this story, that what it is saying, it is saying that only if, let me turn it off, yeah, only if bending moment diagram of a vertical member is in single curvature along the full height of the building, okay, even though with some jumps at the levels where beams and slabs frame into the wall, it should be treated as a structural wall. Fine, I will tell you what it is actually. On the other hand, if it is in double curvature along whole or part of the height of the building, it shall be designed as column. Now what it is saying, that suppose you have, let me just delete all this. Suppose you have a structural wall over different floors, obviously throughout the height, and what it is doing, if you see if I suppose apply some load along, force along this direction, and if I see the moment curvature, so if it suppose it is something like this, So though it is acting as a single, or you can say a vertical cantilever, and due to the connection of the beams here at these levels, I would write it here also. Okay, so at these levels, beams and slabs, so you are getting some peak here. So still it is working. It seems like a I can say vertical cantilever. So this portion of the system or element shall be designed as the structural wall. Okay, I mean the criteria for structural walls are applicable to this. But if in the above story, any of the stories, if it is something like this, okay, here you can see we have double curvature, here we have single curvature, right? Now if it is like that, here we have double curvature. So if it is like that, okay, so we need to design this particular thing as column. That is what our draft code is saying. Okay, so on the other hand, if it is double curvature along whole or part of the height of the building, it shall be designed as column. Okay, so now I will just show you that here also. Let me go to another model. Yeah, so you can see it is a very small model, and up to here we can see a cantilever, vertical cantilever behavior. Sorry, I'm showing you a different thing. Up to here, up to these 2 floors, we can see that there is a vertical cantilever action. But after this, we can see double curvature in the you can say wall. So these 3 floors, the wall shall be designed as, you can say, columns, and these 2 floors, the wall shall be designed as shear wall or structural wall, you can say, right? So this is what this code is saying. Now the problem is that first in the column design, what they have uh, explained, that, let me just remove this. They said that if the B by D ratio is you can say less than 0.4, correct? Am I writing it correct? B by D less than 0.4, that means the D is pretty high compared to the B. So in this case we call it as wall, and we design it as walls, right? Structural walls, right? Now it is saying that based on the curvature of the you can say moment curvature will be deciding. So we have a curvature like this, we have another curvature like this. So this shall be considered as column, I mean shall be designed as column, and this shall be designed as wall or structural wall. Now the problem is, if we provide B by D less than 0.4, we provided a dimension to the section which is having a B by D less than 0.4, and still we are getting a moment curvature like this, dual curvature. Dual curvature means, I mean both side we have this curvature, right? This is what it is writing. On the other hand, double curvature, if we are getting. So the in one case it is saying if it is double curvature, you do not design it as wall, you design it as a column. In the other case, we have this dimensional criteria, or you can say aspect ratio criteria. Okay, so now this is a matter of I mean, again we have a doubt in this particular thing. There is no clarity regarding this particular thing. Okay, so I think the comments will be provided on this draft by the experts, and after that we may get a complete solution to this you can say problems or these questions. Okay, so this is how in the current code and in the draft revision of IS 13920 part 2 for buildings is telling us about the consideration of element as column or structural wall or shear. Okay, so So I hope our discussions will be helping you when we'll be reading this draft code by yourself to understand what is actually telling us and what are the differences that we have with our current code. So if you have any opinion regarding regarding the clauses that we have discussed today, or if you have any different opinion or different suggestions, then please do let me know in the comment box. Thank you. See you in the next lecture.